Chlorine. Chlorine was first discovered by Scheele in 1774 when he heated some concentrated hydrochloric acid with manganese 4 oxide. In 1810, Davy named the gas chlorine, a derivative of the Greek word chloros, meaning greenish yellow. Chlorine does not occur free in nature because it is too reactive. Instead, it is usually found in combined state as chlorides. The most abundant of these is sodium chloride or common salt, which is found both in the sea and salt deposits. Laboratory preparation of chlorine. Chlorine is usually prepared by the oxidation of chloride ions in acidic solution. There are 4 methods. 1. Chlorine can be prepared by the oxidation of concentrated hydrochloric acid using potassium permanganate. This method is very convenient because the reaction occurs readily without heating. Solid potassium permanganate is placed in a flat bottom flask and set up the apparatus as shown here. Concentrated hydrochloric acid is dropped gradually onto it from a tap funnel. A dropping funnel without a tap should not be used, as the poisonous chlorine gas can escape through it. The rate of production of chlorine can be easily controlled, as each drop of acid reaching the permanganate liberates a certain amount of the gas at once. A small amount of hydrogen chloride is also evolved from the concentrated acid. The chlorine produced is contaminated with hydrogen chloride fumes and water vapor. This mixture of gases is passed successively through water, in which the hydrogen chloride gas dissolves and is removed, and then through concentrated sulphuric acid to dry it. The pure dry chlorine gas is collected by downward delivery or upward displacement of air, since it is denser than air. That is, as chlorine moves down, it pushes the air upwards. Alternatively, chlorine may be collected over brine, that is concentrated sodium chloride solution. This is because chlorine is less soluble in brine than in water. Chlorine can be prepared by heating a mixture of concentrated hydrochloric acid and manganese 4 oxide in a round bottom flask. Chlorine can be prepared from sodium chloride. The apparatus used is identical to that shown before. A mixture of solid sodium chloride and manganese 4 oxide is placed in a flask and concentrated sulphuric acid added. The mixture is heated. The concentrated acid acts upon sodium chloride to form hydrogen chloride, which is oxidized to chlorine by manganese 4 oxide. All the above methods involve the oxidation of chloride ions, but chloride may also be conveniently obtained from bleaching solution or bleaching powder by the action of dilute acids. Physical properties of chlorine. Chlorine is a greenish-yellowish poisonous gas with the characteristic pungent, choking smell. It is about 2.5 times denser than air. It is fairly soluble in water, but much more soluble in organic solvents. At room temperature, under a pressure of about 7 atmosphere, it can be liquefied. It is stored and transported in a liquid state in steel cylinders. Test for chlorine. Chlorine is a greenish yellow gas which rapidly bleaches Danley newspaper. damp litmus paper test. Since the gas is acidic, if damp litmus paper is used, a red color is often seen before it is bleached. The red color observed is due to dilute hydrochloric acid, and the bleaching is due to the action of hypochlorous acid. If both chlorine and litmus paper are dry, the above color changes do not occur. Starch-iodide paper test. Drop a piece of damp starch-iodide paper into the unknown gas. If the paper turns dark blue, then the gas is chlorine. Chlorine turns starch-iodide paper blue because it displaces iodine from the iodide. The iodide liberated then turns the starch blue.